All right, so here we have TV production costs. So it says suppose production costs for various hourly production levels of television sets are given by CFP equals 0.16 p cubed minus 8.7 p squared plus 172 p plus $69.4, where p units are produced each hour. Now we're supposed to calculate the marginal cost at production levels of 5, 20, and 30 units. Then find the cost to produce the 6th unit, the 21st unit, and the 31st unit. And then why is the cost to produce the 6th unit less than the marginal cost at production level of 5 units, while the cost to produce the 21st and 31st unit are more than the respective marginal cost? And so what we need to do, how do we get marginal cost? Well, we have to take the derivative here and find that first to get the marginal cost. So if we do that, we'll have 3 times that, 0.48 p squared, and then minus, that's going to be 1617.4 p plus 172 p, and not p, no p there, that gets dropped. And so, and that's going to be dollars per unit. Okay. So marginal cost, C prime of 5, C prime of 20, and C prime of 30, those can be found by plugging in those numbers into our derivative. Now, easy way to do this would be we go in and we plot those. You know, we have our original function, we found the derivative, but we can just do the derivative this way instead of taking and putting it all in. And so we have our graph, and we can just say, okay, well, now I want to trace it. So I want to find the value at 5. Now, I don't want the value of the cost function. I want the value of the marginal cost. So that's $97 per unit. And then if I want it for 20, that's going to be $16 per unit. That's going to be close to the minimum, it looks like. And if I want the 30, that's going to be $82 per unit. So now we plug those values here in. So we had $97 per unit. We had $16 per unit, and we had $82 per unit. All right. So now we need to find the cost to produce that 1 unit. Now remember, when we were looking at the cost to produce 1 unit, it's going to be C of x plus 1 minus C of x. And that's going to give us the cost to produce that 1 unit. Okay. And so what do we have to do? Well, we have to figure out what that 1 unit is. So that's going to be the 6th unit. And so that's going to be the bigger one. And so that's going to be C of 6 minus C of 5 to get the 6th one. And this is going to be C of 21 minus C of 20. And this is going to be C of 31 minus C of 30. Okay, so now we need to find all of these values. And so again, using our graphs we already have, we can go in and say, okay, well, I want to find C of 6 and C of 5, or 30. Well, let's go backwards. Let's do 30. So now I need a cost function. So now that's going to be 1719.4. Then I need to find what it is for 31. That's 1807.26. Okay, all right, got those written down. Then we need the 21 and 20, 1326.46, 1309.4, and then we need 6, which is 822.76, and then 5 is 731.9. So we'll plug all those in here. So we had the 822.76 minus 731.9. And if we take that, we get 90.8, oops, 86. And that's for the 6th unit. Here we had 1326.46 minus 1309.40. And so that gives us 1706 for the 21st unit. And then here we had 1807.26 minus 1719.40. and that gives us 87.86 for the 31st unit. Okay, now they say, why is the cost to produce the 6th unit less than the marginal cost at the production level of 5 units? So why is this less than this? And then why are these two more than these two? So why are these two more than those two? Okay, well, let's look at our graphs again. What do they look like? Okay, so here at 5, we're going up here, we're concave down. So that means as we go further up and get closer to that peak, what's going to happen is we're going to get less steep a curve or a linear line for the tangent. So that the tangent at 5 is going to be less than the tangent at 6 as far as the slope goes. And so that means this one is going to be a higher value than if we go up to the next one. Okay. Now, what happens up here? Well, where is 20? Well, 20 is right here. So we're just coming off of getting close to that 0 point here where we have that uh, the min here. So that's going to be somewhere about here. And so that was at 0 where we had the horizontal tangent. And so now we're starting and we're going to start getting building up. And another way to think about this is we have that when we have the tangent, we're going to overestimate the next thing above it. So if we had the tangent at the 5, at 6, it's going to be less than where that tangent line is. So we're underestimating or we're overestimating what the tangent is compared to that. And so that's why, it's going to be 97 versus that 84 point, or no, 90.86. Sorry. Let's go back here. So when we have, the point here, we have something like this. When we take that tangent, if this is the 5 and this is the 6, the tangent is overestimating what it is going to be for here. So that's why this is larger than this because of the overestimation. Whereas, if we come here, we're just past the 0. So what that's going to do is that's going to underestimate the next one. So this is underestimating what the actual value is. And so that's why these two are going to be more, because now we're on the other side, we're concave up. And so that's going to be always underestimating the derivative versus the actual values. And so that's kind of why it's because of our tangent lines overestimating on concave down, underestimating on the concave up. And so that's why we have what we see here as far as why this one's less, these are more. And I'm not going to write all that down, but that's the reasoning why. All right, so let's pause there and we'll come back for more.